Thank you all for coming. I'd like to talk about technology change that's been taking place over the past few years and try to understand it and try to understand what we can do with it. So I'm assuming that we're all Java developers to some extent, and that we're all kind of interested in JavaScript, and that we're investigating that. And I want to give you an overview of the whole ecosystem and what is inside of it and what you can do with it. And I'm sure there will be pieces in here that you've never heard of before. Some parts I'll be talking about are completely new, so hopefully it will be interesting. Let's start by something that somebody told me recently, something that you could call the 3 stages of responsiveness to change. So when you're just born, you look around you in the world, and everything is fresh and new, and you're excited about everything, and everything is shiny, and you accept it. Everything around you, that's just a default situation. Then, when you're in your teens and maybe in your 20s, when there are new things that come up, you are very excited, and you think it's revolutionary. Anything that's new when you're between your 15th and 35th birthday is kind of exciting and new, and you want to explore it and you want to use it. Now, this guy. This is several people probably in this room and several people that you work with, and maybe this is you. When you're maybe late 30s, early 40s, and later, when there are new technologies, you try and fight it. You try and deny it, and you say, no, this is stupid, and it doesn't make any sense, and I don't understand, and this is completely silly, and it's exactly the same as 10 years ago, but worse, and these kinds of things, you know? This is me as well, you know? I'm that guy, actually. So I want to take us out of our comfortable place where we are, and we're kind of in this house where we've been living for a long time. Many of us, especially if you're like in your 40s and you've been involved in the Java ecosystem or using Java in different ways for a long time. You know, you're in your house and you've got your libraries and you've got your Java friends and your jugs and your discussions and so on. And I want to take you on a small walk, because we know that below this place where we're living, there's this big unknown space, and we're kind of worried about what that means, and you know what is in there, and we're concerned about that. And I'd like to just show you what that is, and maybe it's actually different to what you think. Maybe this whole space is different to how you've been looking at it. Now, I'd like to first of all talk a little bit very briefly about what I think has been happening in the last few years, which explains why JavaScript has become as popular as it has been, and why it continues to be popular, and it's growing exponentially, and everyone wants to be involved in JavaScript. I would say the first reason for that is that there are now multiple devices. A year or 5, 6, or 10 years ago, we weren't concerned at all about responsive design and about changing the resolution of an application, because we only had one resolution. So one thing that's happened very clearly is that there are now many different devices, mobile phones, tablets of various kinds and sizes, in addition to our desktop computer. But in addition to that, the browser is everywhere. Now this is something that we would not have predicted some time ago. I mean, as a Java programmer, I have always thought the JVM would be everywhere. And as we'll see, the JVM is everywhere, but on the front end, what is definitely everywhere is the browser. So on all of those different devices, one thing that those devices have in common is the fact that the browser is on all of them. The browser is on your iPhone, on your Android, on your tablets, on all those different things. That is where the browser is found. So understandably, everyone wants to write applications that access all of those devices, and the most obvious candidate, the most obvious platform that you want to write towards is the browser, since it's already there. That platform is everywhere. And what that leads to, and what is related to that, is the development of spas. So everyone nowadays is interested in creating single-page applications. And it makes complete sense, of course, because everyone is targeting these kinds of devices. And you want to keep things simple, and you're concerned about the battery life of the of the user, of the person using the application, and the network bandwidth, and these kinds of concerns. You want the application to be as simple as possible. And where in the past, a couple of years ago, all the innovation in frameworks was on the Java side, on the Java server side, you would see that all these Java server frameworks were focused on things like navigation. That was a key concern of all the different server frameworks. Struts, JSF, Wicked, all these different Tapestry, hundreds of Java server-side frameworks. A primary concern was navigation. And now when you look at what is happening with all these mobile devices and different screen sizes coming out, what you would ideally want is no navigation. A simple application, a single page, providing simply what the application is about, and it tends to be a very specific function that an application has. It is like one feature, you know. Feature is book a room in a hotel, or the feature is go to the store and buy goods, or these kinds of concerns. Very specific, very focused applications. That is really what a lot of the, a large space, what these applications are focused on. So I would say that over the last couple of years, we've really seen a combination of these three different factors, these three different changes in technology and changes in what people are focusing on, leading to the popularity of JavaScript. So there are multiple different kinds of devices, different screen sizes, the browser is on all of them, and everyone is kind of focused on creating single-page applications. And this underpins this big switch to JavaScript. So I want to address these changes by giving you 10 building blocks or 10 tips, really 10 tips for you as a Java developer entering this landscape, and basically around 4 different themes. So we're going to look at the fact that before we even look at JavaScript itself, I want to look at what the HTML landscape is about right now. HTML has changed significantly with HTML5, and you know, everyone talks about multimedia and so on, but there's actually more to HTML than that now. There's real components that you would expect to find in an application framework. And secondly, I want to look briefly at CSS, and everyone is convinced or believes that CSS is all about responsive design and changing resolutions and so on, but I want to suggest to you that there might be a better way of approaching that, that particular problem. Then I want to very briefly look at the many different libraries that are out there, and then kind of more philosophically look at what JavaScript is in this context in the browser, and talk about JavaScript as the assembly language of the browser, and ask ourselves honestly that just because the browser needs JavaScript, do we as programmers need to code in JavaScript, and what the alternatives are there. And I want to do quite a few demos just to make it kind of concrete to you as well at the same time. So the first tip number 1, and it's very similar to what Reza was talking about microservices. Resist the hype. Don't assume that all your customers want to use all these new technologies. Don't assume that your application fits exactly within the space where it makes sense to use mobile devices and the browser and so on. I want to give you a very specific use case. An air traffic control system. There isn't one single air traffic controller in the world waiting for their application to be on a mobile device. They do not want to be in control of landing and controlling an airspace, landing planes and controlling an airspace on a mobile device. There is a very large segment of software development that continues to need the traditional materials, the traditional desktop, the traditional traditional Java, the traditional Java desktop. So, for example, when there's data-heavy monitoring systems, often these kinds of applications are behind the firewall. Sometimes you find that the requirements relate to large screens and large resolutions. And in the case of air traffic controllers, they're all in the same room. Often you find that these kinds of applications that are written in this particular space are aimed at a group of users who are in the same room. Now, what possible need do they have for a browser-based application? Even if you were to write a browser-based application for these users found in the same room, what would be the point of that? So, actually, in relation to that, I would suggest a tip 1A to bring these types of users into this new material space is you could create a mobile app to extend the systems that they already have. You could create a web app to provide management level materials. and information to the upper management of the organization, and then keep the application exactly as it is. I've come across several situations where it is not the users of the application that want the application to be browser-based, but it's the management of that application. People who don't even use it are saying, we need a browser-based application. We need our application to be on a mobile phone. And the users of it are the ones who are resisting and saying, no, that doesn't make any sense. And then within development organizations, I'm seeing management of consultancies and development organizations saying, we really need to be on this space. We need to be learning about JavaScript right now because this is so important, without even questioning whether it makes sense to the users of the systems that are being developed. So my first step would be to really resist the hype and to question whether your users of your systems actually need to have a full-blown web-based application, a full-blown mobile application, or whether maybe you could create a simple mobile app that receives urgent notifications from the air traffic control system or something of that kind. So that would be tip number one, resist the hype. The second tip is think of HTML as more than what you think it is. Think of it as an application framework, because it now comes with a bunch of components and new features that are often overlooked. So the original idea behind HTML was to provide tags like H1 and P and so on to mark up some document. But as most people probably know, with HTML5, we have all these new multimedia-related components. So we have video, and we have audio, and there's semantic markup that you hear about sometimes. But there's actually some interesting additional features to that. So I want to give you a quick example of this, but there's a lot of new components and elements and attributes that are part of HTML now. But the underlying principles in general of HTML5 are, first of all, that every new component that is created within the HTML specification should be based on HTML, CSS, and JavaScript. There should not be a need for external plugins like Flash. That error handling, now error handling is truly a application framework type concern, should be incorporated, that there should be more focus on markup, and understandably that it should be device independent. So to give you a very quick example of one of these components, now this is native HTML5 that I'm showing you. There is the data list component. So what we have here is, on line 12, an input element. But what is special about this particular input element is that it makes use of a new attribute called list. And what list does is it is used to identify an element that lists predefined options suggested to the user. So there you can see that the attribute has as its name list. And there is another HTML element called data list here with an ID set to country. So because list and the ID of data list are the same, that input element is going to be populated by the options within the data list. So let's run this application, and we'll see how that looks. And we should open our browser. And here it is. So here's country. And you can see that I have populated the list with these. So what you can also see is that as I type, there is a filtering built in. So this is a native HTML component that provides auto-completion, an auto-completion element in your page with filtering that is built into it automatically. And you can also see that once you've selected an item, and you go into the auto-completion again, that the last used item is remembered as well. So natively built into HTML, you now have auto-completion, and there are more components like this. So a second tip would be to take a look at the HTML specification and at the components that are built into it. And you may end up removing several components that you might have created via JavaScript or via jQuery or some library that you're using. You could replace those with native HTML application-like components that are now part of the specification. And what is related to this is that each of these components, each of these special HTML components is constructed out of HTML and CSS and JavaScript. And that too we can see. So I'm going to just select this item here in the browser. and I'm going to inspect it. So I'm selecting it here, and now there is a little tool, browser DOM, which enables me to inspect that item that I have selected. I'll make this a bit smaller, and I'll make this one a bit smaller too, so I can see them next to each other. Okay, so I can see as I click on an item in the browser, I can see it highlighted back in the development tool. So now I'm selecting that drop-down, and I can see it selected here. And now I can browse into its content, and this is called a shadow root and a shadow DOM. So there's a DOM that you don't see and that you don't work with directly in the HTML, but that you can browse into, and that you can assign CSS rules to and apply them directly in here. So HTML has become a lot more interesting. Now, related to this, let's see where we are. Related to this is, of course, CSS. And CSS, in the meantime, is different to what it used to be. Originally aimed at simple markup and providing styling for markup. But with the latest release, there is a big focus on modularizing the CSS specification. So there isn't one CSS specification anymore. There's actually 50 different sub-specifications. The main one that everyone knows about is media query. But media query is maybe different as well to what you might have thought. So media query gives you the possibility of setting a maximum width of a particular resolution, and then provide content based on the width that you've specified, responsive design. However, did you know that what CSS does is it does not load and unload content from the DOM, but it shows and hides it. So just because you're not showing something does not mean that it hasn't been loaded. And I want to show you this by means of a small example. And at the same time, I want to show you an alternative way of doing that, using some useful JavaScript libraries. I have here a simple application, and I run this. I want to warn you, it's not a beautiful application. It's a simple demonstration application. Now you can see that we have here, I'll make this a bit smaller, if I can. Okay. You can see that we have here two images, and we also have here, you're using a large resolution. Now, if we make this smartphone portrait, you can see that those images disappear, and you can see that you're using a small resolution. So, great, that's responsive design. But let's see how that responsive design is implemented. So we go back, and let's take a look in this browser DOM. Okay. So now we have it at full resolution, and we can see that we have that bottle, okay? And we can also see that we have that logo. And you can see that we have a large resolution. So those are the three items. Okay, so now we'll make it smaller. And we'll make it smartphone portrait. And what you see is the bottle is still there, even though it's not visible. And the others are gone. So we inspect the source, and what you see here is that this particular showing and hiding implementation is done via a media query. The other one is more interesting. So that was the bottle, but the Coca-Cola logo. How is this one done? Now here it is. Now this is done by means of a JavaScript framework called Responsiveness. So if you want to do dynamic loading and unloading, forget about using CSS. And instead, one approach is to use Responsiveness. And we can see that if you look in the business logic here, you can see that this is done via JavaScript. You can see that we have here a response.create and a response.action. So Responsiveness allows us to set breakpoints, 0, 480, 481, and then, so that's the creation of the breakpoints. And then there is response.action, where we can say, well, if that particular breakpoint is hit, then set a particular property to a particular value. And then in our UI, we can say, if that property is set, then show or hide what we want to show or hide. So that's the second way of doing it. But the third way is, you can see this here, you're using a large resolution And in this case, you can say, if we can see if we change this using a small resolution, where does that come from? Now that comes from a different way of doing the same thing, and this is called foundation interchange. So take a look at foundation.zurb.com. And again, we have breakpoints, small, medium, and large. And for each of those breakpoints, we have assigned an HTML fragment. So these are simple, these are really genuinely HTML files. And each of them is shown depending on whether the resolution switches to the specified breakpoint. So I'm looking in the HTML, in the fragments here, so large, medium, and small. And if you're working with microservices, this could also be very useful because depending on which resolution is current, you could be loading and unloading a different HTML page, which could be accessing a different REST endpoint. So each of those different endpoints could be accessed via a different page in your application that is loaded or unloaded, depending on how foundation interchange is set up. So that would be my second tip. Actually, evaluate responsive JavaScript as much as you are evaluating responsive CSS. Okay, and then comes the big question, of course. You've looked at HTML, you've looked at CSS, and you've examined what is useful there. And now you're going to evaluate which of the frameworks you're going to use. And there are as many new frameworks in JavaScript as there once were in Java. It used to be that you would wake up and you would find, wow, there's a new Java server framework to learn. And next week there'd be another one, and there'd be another one. And everyone would say, this is the best framework, it solves all the problems of the one before. And you would learn that, and then you would find there's another one that solves those problems. And that kind of innovation is now happening in the JavaScript space. Now, the simplest solution when you're doing this kind of evaluation is to say, well, Angular, everyone is using Angular, everyone's talking about Angular, let's use Angular. Angular is definitely, I'm sure everyone here has done something with it or played with it or heard of it at least, provides a full stack application framework, gives you everything you need. You can take Angular and you need never look at anything else again because it's got solutions for every imaginable problem. Now, a different approach to taking Angular is to build up your own framework, essentially, or to put the pieces together yourself. If you decide, for whatever reason, Angular is not for me, then there are a number of other libraries that you need to look at to build up your own stack. And there are definitely advantages, of course, because then you're not locked into a particular framework. Then you can explore other options and be more flexible and create a modular solution based on the component libraries that are relevant to you. So you would examine as base JavaScript libraries these ones as a starting point. Prototype, Dojo, jQuery, MooTools. On the lowest level, these are the simplest JavaScript libraries on top of the base JavaScript language that you would need to explore. So, you would also have a look at Grunt and Gulp. And Grunt is a build system like Ant is, and like an aspect of Maven. A part of Maven is building an application, and Grunt is the one that everyone was talking about 2 years ago. And currently, everyone is talking about Gulp, and Gulp is the one definitely to use. And if you've never heard of Brunch, it means you're not up to date, because everyone that was doing Gulp last week is doing Brunch today. Brunch is the new Gulp, really. So. Good luck. and by the time we finished, there'll be something else. These frameworks are constantly changing, and it's a good thing. I'll talk about that. It's a good thing. So then you're going to look at other frameworks like Backbone, which is very popular a couple of years ago and a bit less popular now. Ember, Knockout. Knockout is interesting because it focuses very narrowly on one particular thing. It just does two-way data binding. So to I'll give you a very small example of that. If you're on the Knockout page, they have many tutorials, but the simplest example, a Hello World example, let's see if we can make this bigger, well, maybe too big, is, you can see here, we have an HTML, this is the HTML view, and we have a view model. This is expressed in JavaScript. We have properties in JavaScript which are mapped to these to the view via this data bind attribute. So in your input elements or in any element you like, you can have an attribute called data bind, which maps a property to a matching property inside of the JavaScript. And that's all that knockout does. And it's a nice basis for many other solutions, as we'll see a bit later on. So at some point, you're going to find yourself online and you want to compare which of these frameworks is most popular. And you're going to go to a site like Indeed.com, and there's many other places where you can just type in different framework names and see how popular they are. But be very careful when you do this, because you must really know what these statistics represent. And now when you see this very sharp blue line going up, that's Angular. 2013 is the top one, and the bottom one is 2015. And the end of that blue isn't Angular crashing, it's just they haven't got the latest statistics yet. But the point is, you can see, if you look at this graph, these two graphs, you can see that between 2013 and 2015, it seems like all the other frameworks have flatlined and are not being used at all anymore, and only Angular is being used. Now, in reality, it's not like that. But when you look at these statistics, it seems like that. And what this actually shows you is the interest that people have when they are searching on Google in a particular framework. It doesn't say anything about what people are actually using. It just shows you the results of searches on Google and wherever on search engines. And it's definitely an indicator of where the interest is. But for all we know, all those people who are on the blue line have investigated Angular and decided, no, we don't want to use that at all. That's a possible outcome of this graph. So be very careful with these kinds of statistics. In general, consider your requirements, as always, in the same way as with the air traffic control system. Don't make a mobile app for air traffic controllers. Focus on what your requirements are and what is relevant to you. So if you're very focused on MVC structures, that's what Backbone is all about. It's all about MVC. Knockout is very narrowly focused on two-way data binding, and if you like a complete package, being completely, providing completely everything, then Angular is definitely the interesting framework to choose. Now then, of course, many people in here might be thinking, well, what about React? Well, indeed, many people who were doing Angular 2 years ago are now doing React. I was at a conference recently in Norway where I asked people, so what do you think about Angular 1.3 versus Angular 2? And I said, we don't care, we're using React. So there's a lot of new interest in React. And if you follow that trend, then you need to also get into the whole React ecosystem, which has its own sub-frameworks and libraries that relate to that to that particular ecosystem. So then you're in a whole different particular rabbit hole. One way to approach the problem, and there are component libraries, many component libraries. What is interesting about component libraries is several of these used to be Java server-side component libraries. So Primefaces and Kendo, they started out making component libraries for JSF. Especially Primefaces did that. And you can see how popular JavaScript is becoming because they are creating those same kinds of frameworks now for JavaScript. And in the same way as in the Java world, there are different testing solutions, TestNG and JUnit and mocking libraries and so on. The JavaScript world has the same, and there really is everything you would imagine needing. Some fit better with the frameworks you choose. So if you've chosen Angular, then Protractor would be a good testing framework to choose along with that, because it's created by the same organization. And then at some point, the reason why we're doing all of this is because we want to be on a phone at some stage, right? So there's jQuery Mobile, there's Cordova, which lets you generate a native app from your JavaScript application quite easily. Or a semi-native app with a specific browser for Android and a browser for iOS, more or less native. And the Ionic framework is definitely an interesting one to explore. So this provides a lot of tools and features for doing mobile development for JavaScript applications. Ionic is definitely a very useful framework to use. And there are kind of miscellaneous other ones that are quite popular and that everyone's talking about. Yeoman, very useful if you want to scaffold an application. So you can type Yo Angular and it creates a whole Angular application skeleton for you. Bower, comparable to Maven, works with dependencies. So you can declare your dependencies in a Bower file, and then Bower can download all of those for you. And Node, so you could, if you use Node, you can forget about doing Java or anything else on the back end and just focus on JavaScript, completely from the front end to the back end. Those are all options. Tip number 5 would be definitely incorporate modularity. And we don't have much time to do this, but if we have time, I'll show you a quick example. But Require.js and Browserify. I think Require.js is the more popular one. Really think about modularity, especially if you're creating a large enterprise application and not something very quickly to throw away. There are modular solutions, and ECMAScript 6, the latest version of JavaScript, comes with modularity built in as well. So there are solutions for modularity. Tip number 6, evaluate the abstraction. So you don't need to necessarily work directly in HTML and CSS and JavaScript. You could use Emmet. So Emmet is a useful tool for doing HTML. Sass and Less are preprocessors for CSS, and there's CoffeeScript and TypeScript and more if you want to avoid some of the typical pain points like the absence of a type system in native JavaScript. Okay, so clearly there's a lot of change in this whole space, and my tip number 7 would be to not worry about it. Don't worry about it. That's just the way this particular ecosystem is. That's just the way it is. The lifespan of most applications created in the JavaScript world is about the same length as a particular release cycle of the favorite JavaScript library that you're using. In the beginning, for example, with Angular, when the announcements came out about Angular 2, that it would not be backward compatible. And in the meantime, there's been a compromise. But when that first announcement came out, there were many people saying, oh, this is terrible, and this is the end of Angular. But after a few months, most people were okay with it, because they knew that by the time Angular 2 came out, they would be rewriting their application anyway. Because no one is creating massive applications with millions of lines of code in JavaScript. So most people are creating small to medium applications anyway that have the kind of lifespan that is quite short anyway. So in most cases, people don't care that much that things come and go so quickly. And also the reason why things come and go is because the underlying hardware keeps changing. So people are happy with changing technologies because they keep track with the hardware changes. So things go fast. But this has a number of consequences. So I think we are entering a new world where people will be writing increasingly unreadable code. What's the point of writing readable code if no one's going to read it? Because you're going to rewrite your application anyway. You know, how strict should you be in writing maintainable code? These are honest questions to ask, because in a year and a half, you're going to have new frameworks to use, and you'll be writing your application from scratch. Yes, so things change fast, and it might lead to unexpected side effects. And I want to tell you a new acronym here, from WARA to WANTA. Okay, WARA everyone knows, right, in the Java world, write once, run anywhere. I want to tell you about a new one, and you heard it here first, write once, never touch again. And again, there's nothing wrong with that. There's nothing wrong with that, okay? It's just the way things are. You're writing a quick app, you want to put it on the phone, you know, you want to get people registered for a concert, you know. These are very simple apps, you put them out there, and then you never touch them again because the concert is over and you have to write something else again. So these things change a lot. So I want to get a bit more serious and point you to a couple of my last 2 tips are quite serious solutions that you probably have never heard about. I want to give you, as tip number 9, evaluate what corporations are doing. So that's interesting in itself, that corporations, large organizations are not saying, well, this is rubbish, we're not going to do that. We're going to do more maintainable, sustainable things. They're saying, this is interesting. And a lot of organizations, large organizations, have their own frameworks that they have been developing internally and that they gradually expose externally. So one that I found very interesting, that's why I do my banking. So I went to a conference and they announced, hey, we have a framework that we created on top of Angular. So they use Angular as a starting point, and then they add their own business components to create those nice colors that are, you know, orange and stuff, and all these menu bars and things. If you want your application to look something like that, then you can use the business components that ING has made available. And it's actually on GitHub. So a lot of these things are going straight to GitHub, straight to open source. So you can go to github.com/spectingular and you find this particular framework. IBM has one, Google has one, Salesforce has one, and since last week at Java 1, Oracle has one too. So there's actually a new framework created by Oracle in the JavaScript space. And this particular framework is called JET, Oracle JavaScript Extension Toolkit. And it uses all of these other libraries. So it is Knockout plus Require plus jQuery plus jQuery UI. And on top of that, there are JavaScript components for data visualization by Oracle. So that's the idea. And one quick slide on it. So there's a website you can go to, oraclejet.org, and there's a Twitter handle. And it's really focused, in the first place, it's focused on the Oracle customers. So right now, if you're an Oracle customer and you have bought Oracle Mobile Cloud Services, then you will freely be able to use this in production. But if you're not one of those people, then right now you can go to the site anyway. And I have the site up here, oraclejet.org. This is what it looks like. You can go down the page, and what you see along the page at the bottom is the libraries that it uses. So it uses jQuery, jQuery UI, Knockout, Require, Hammer. So Hammer for touch. So this is a nice library to use for mobile apps. And then there's JET, and JET is simply a bunch of components. So to show those, so there's a cookbook online with snippets built into it. So these components, for example, maps and charts and things like that, and graphs, the ones that people might know from ADF and ADF faces, they are now in JavaScript form and can be plugged into any other framework. So, for example, here's a dial gauge, and these actually work directly in the page. So I can use it directly in here. I can change the code directly inside of this cookbook to tweak it. So here is the starting point. So there's a plugin for it for NetBeans, and I've installed it, and then you can create this application, but you don't even need to use NetBeans. You can just simply download the zip file. It's completely free. You can go download and install. You get a zip file. You unzip it, use any editor you want, and what happens when you run the application, so I haven't touched it, I've just opened it. When you run the application, you get this. Okay, so you have a basic template as a starting point for creating your own application. You can click you have different tabs along the top, and what is really cool, and that is built into this, if I can switch to, or if I switch this smaller, you can see that automatically there's responsive design. So automatically responsive design is built into this. And so to show you how quickly you can create these, use these components, so here is JavaScript and here's HTML. So I'll just copy this HTML and paste it in the home page HTML file. Okay, so here I've just pasted it in, exactly from the cookbook. And then I go to the matching. So you can see here all the libraries. Here's all the JavaScript, here are the templates. So this is home, and I'm going to go to the home here. And I have this gauge stuff set up. So now if I go back to my page, let's run it again. There's my gauge, right? This is my gauge. So I didn't need to do very much. And now, how would you bind this to something else? So how can you use that value? And this is just pure knockout. So I'm not doing anything JET-like right now. I'm saying span. I'm using data bind, and I'm binding the value of the span. The text of the span to this property, gauge value. Okay, so here, current value. Okay, there's current value. I look back on the page, refresh the page. Okay, the current value. You can see that it changes. Okay, fine. Not very exciting, but let's now use input instead. So input and data bind. And here I take the value and I connect it to the gauge. And so now I have two-way data binding. I can bind it both ways. So refresh the page. And so now I can type something here and exit, and you can see that the gauge updates itself. So it's just that the programming model is based on open source libraries, and the only difference is that we have a bunch of JavaScript components built provided by Oracle. And this is going to be open sourced during next year. This is going to be on GitHub. You'll be able to get all these components and libraries and so on. And that is the plan. The final tip, very quickly, is you could look at JavaScript as assembly language. Now, that's kind of maybe a strange thing to do. But if you look at what assembly language is, it's low level, and it's always focused one-on-one on a particular architecture. It's a language written for a particular architecture. So you could see JavaScript as being language for the browser in that same way. So you might think, okay, so this is assembly language, right, for IBM PC and etc. How is JavaScript like this? Well, look at JavaScript again, okay? This is JavaScript, right? To me, it looks a lot like assembly language. To me, that's not something I want to be coding myself, that kind of stuff, right? I don't know. Maybe you're different. You know, it's not a unique comment. I'm not alone in saying this. Even the inventors of JavaScript have said, and it's not a derogatory thing. JavaScript is the assembly language of the web. So what that means is there are multiple different ways of transpiling your existing code from another language into JavaScript. And if you go to, there's a GitHub place you can go to where you see hundreds of transpilers. And there are also some for JavaScript. So there's kind of solutions for people who don't want to code in JavaScript that much. So there's CoffeeScript, TypeScript, Dart. It's kind of unclear where that is. A lot of people know about Vaadin, but I want to talk briefly about JavaScript. Okay, so Vaadin is based on Git and Google Web Toolkit, and it's all about coding in Java, and Google Web Toolkit changes that into Java for you. But JavaScript does the same thing, and this is a very interesting project to take a look at for true Java fans. If you go to JavaScript.com, you'll find a very interesting page. And there's a company behind it, and there are use cases, and there are many examples. The idea behind JavaScript is that on all the different devices, there is some form of JVM. And on all the different devices, there is some form of an HTML viewer. And what JavaScript does, it connects those together. And there's a difference between Google Web Toolkit and JavaScript. With Google Web Toolkit, you do all your coding in Java. Front end, back end, all your coding is in Java. And Vaadin is especially nice if you know Swing already, because you're using a similar component hierarchy in Vaadin to what you did in Swing. But what is special about JavaScript is that you write your view in HTML and your logic in Java. So it means you can hand off your HTML to some kind of web designer who gives it back to you. And because knockout is used here as well, it uses knockout bindings to connect the HTML to the Java. Now, how it works is like this. Schematically, on the desktop, we have Hotspot. On Android, we have Delvik. On iOS, we have RoboVM. On the web, there is JavaScript's own transpiler. So in the project, there is a transpiler from Java to JavaScript. So on all the different devices, there is some form of Java, and there's also some form of web browser. So what JavaScript does is it combines all of those together. And it does this by means of Maven archetype. So I have here, and it's Maven archetype, so you can use any IDE or editor you want. So I have here checked out one of these archetypes. So in NetBeans, I go through some steps. So I can say, so I type something here, type something there. On the next page, I say, where do I want to deploy the application to? So Android, iOS, browser, I can choose, and I've made some choices already. So I get a Maven archetype that is set up to generate an APK file for Android. It's set up to create a JavaFX file, JavaFX application, and also a web application. So I take one of these. So here's where all the coding goes. So now this is exactly the same as what we saw in the knockout page. So if I go back to knockout. Where was knockout? Okay, we go to the live examples. So here was the hello world that I showed you before. There's an HTML side and a JavaScript side. Where is it? Okay, there's an HTML side and a JavaScript side. So on the HTML side, so here I go into the web pages. So here's the index file. This is exactly the same as on that page. Once we copy it there. So let's copy this. And I paste it in here. Okay, so here is the view. View is done exactly as before. Now, on the Java side, I have here a first name and a last name, which I had here as JavaScript, observable properties, and I have a computed property, which is full name. And here is the computed property, which is full name, which combines the first name and the last name. Now, the wonderful thing is I have a type system, so I can use code completion here. So to initialize this, I can use code completion, set first name, set last name, and I can do refactoring and all these things I can do much better because we have a type system here now. So if I run this application, I will have a JavaFX application that works to the user exactly the same way as the other app did that Knockout creates via JavaScript. So that's a simple example, but a more complex example is we can combine the JavaScript framework from Oracle with JukeScript, meaning that we can create our JavaScript extension toolkit applications not in JavaScript, but in Java. So if I switch to the libraries view, now here we have that same gauge that I showed earlier, but all the coding I did for this, I did in Java using JukeScript. Because already, last week, this Oracle JavaScript toolkit was announced, and 2 days later, the guys behind JukeScript, who are completely unconnected to Oracle, they just thought, hey, this is cool, we're doing Knockout, and they have a JavaScript solution on top of Knockout, created their own solution. They integrated Jet into JukeScript. So this is a JavaFX web view that contains one of those components from Oracle Jet. And I can also create an APK file and any other kind of file that JukeScript supports. So there's a lot of innovation in this particular space. With that, I probably have like half a second left, or minus 2 minutes. Very quickly, these are the tips I want to leave you with. Resist the hype. Look at HTML5 again. It's got more than you think. And maybe you should forget about CSS, because what it really focuses on is media queries, whereas JavaScript does it better if you choose the right JavaScript libraries. And Oracle Jet has this incorporated too. Evaluate the framework versus libraries, look at modularity, look at things like SAS and less, and don't be too stressed about the fact that the things you are learning today are out of date tomorrow. It's not about the frameworks and the technologies, it's about your coding style, and it's about the way you approach your coding, it's about your architecture. And if you architect your application correctly, then the fact that the frameworks are coming and going all the time shouldn't be a big problem. Thank you very much.